Okay, today I'm going to do chapter 6.2, okay, the distance time graph and speed time graph. Okay, these are the notes that you should copy into your notebook. I will not bother even reading it to you. This is all knowledge that you should know from physics. Okay, so you should have learned this last year under kinematics. So just pause the video now and just copy these notes, right? This is the basic idea that you need to know. For example, gradient of a distance time graph is the speed, while gradient of a speed time graph is acceleration. Area of a speed time graph gives you the distance traveled. So pause video now and copy the notes. Okay, now that you have copied all of this, we will start with the exercise proper. Okay, and I will do exercise 6.2, question 1. So please refer to your textbook, alright, for question 1. Okay, question 1, right, they say find the speed of the cyclist during a period represented by OA. Okay, if we look here, OA is here. So simply, right, the speed, right, from a distance time graph will give me the gradient of a distance time graph will give me the speed. So in this case, right, all I need to do is take the rise over the run for OA. So the rise here is 20, the run is 1 hour. Okay, so it's 20 km. Okay, so in this case, my speed is simply equals to the gradient, which in this case is rise over run, which is 20 over 1, which is 20 km per hour. Simple enough? 1A1. Okay, next one that we do is 1A2. AB. Okay, speed at AB. If you notice AB, for flat line, what's the gradient? Okay, the gradient for flat line is 0. Straight away, we know that the gradient here is 0. So speed, in this case, don't even need to do calculation, is 0 km per hour. So if you need to describe it, the cyclist is at rest. Okay? And finally, we have 1A3. 1A3 says that the BC. Okay, BC in this case, what we need to do, right, is to find the gradient from at BC. So if you notice here, be very careful. The rise, okay, the rise is not 40. The rise from B to C, the rise down here is actually 20, and the run is actually 1.5. Here is 0.5, here is 1. So the rise is 20, the run is 1.5. So what we have here is rise, which is my speed, is equals to rise over run, is 20 over 1.5. Okay, then now if you were to quickly punch the result into the calculator, you should get 13 1/3 km per hour. Try to leave it as in fractions whenever possible. Try not to write 13.3. 13 1/3 is a exact value, so you can write it as 13 1/3. And finally, they ask you for average speed. Again, from primary school, average speed, okay, is equals to total distance over total time. So in this case, my total distance, right? What's my total distance that the cyclist traveled? 0 to 40, the cyclist traveled 40 km, and total time that the cyclist traveled is 3 hours. So total distance is 40 and total time is 3 hours. So if you simply take this, you should get 16 2/3 kilometers per hour. Very simple question, and we are done with question 1. Now I present to you another question. This time I'm going to do a question on the speed time graph. Okay, speed time graph, I'm going to do question 3. This is an introduction. So first and foremost for question 3A, part 1, they say find the acceleration of car A. From our notes just now, okay, if you want to find the acceleration from A, speed time graph, acceleration is the gradient. Gradient of a speed time graph gives you the acceleration of an object. So for 3A part 1, I'll find acceleration of car A. So gradient, okay, very simple, for car A is rise 20 over run, which is 25. So I'll write my acceleration is equals to rise over run, which is the gradient, which is 20 over 25. Okay, a meter per second square. Okay, please note the units also from physics. You have 4/5 meters per second square. That is for car A. Now car B, same thing at time t equals to 20. Alright, this is a slight trick question. They ask you what's the acceleration here, but you notice right throughout the time it is a straight line. The gradient is constant from 0 to 25 seconds, which means that the acceleration, since gradient is the acceleration of a speed time graph, it means that throughout here, whether it's here, whether it's here, whether it's here, the gradient is the same. If the gradient is the same, it means that the acceleration is constant from 0 to 25. So instead of just saying, oh, at 20, then I can't read this value over here, I must also take the gradient of the entire line. The rise in this case is 15, the run is 25. So straight away I say that my acceleration is equals to 15 over 25 meter per second square. Okay, I have 3/5 meter per second square. And that concludes 3A part 2. Now I need to do 3B. Find the difference between the speed of car A and the speed of car B after they have traveled for 10 seconds. This one, simple reading of graph. At 10 seconds, speed of car A is equals to 8 meter per second. Speed of car B is equals to 6 meter per second. Here you read is 8 meter per second. Here is 6 meters per second. So therefore in 3B, okay, the difference is equals to 8 meters per second minus 6 meters per second. The difference is 2 meters per second. And finally we have 3C. The distance between A and B after they have traveled for 20 seconds. Okay, 20 seconds is down here. What we need to do right now is to find the distance traveled by A and B. Let's refer back to our magic paper. Okay, how do I find the distance traveled by an object for speed time graph? It is the area. Alright, so now area of A, notice that what we have is the area of a triangle. For B is also the area of a triangle. So now I'll say that the distance, okay, so I take the distance traveled by A minus the distance traveled by B. So of A is half times base, which is 20, times height, which is 16, minus half times base, which is 20 also, times the height, which is 12. Okay, so what I have here is the difference in the distance is 40 km. And that concludes my examples for exercise 6.2. So stay tuned for more examples for 6.2. Thank you for watching.